twin primes. We did prime, we did co-prime, abhi we are doing twin primes. Two prime numbers, he says two prime numbers which have only one composite number between them are called twin primes. How do we imagine it? We have a prime number over here. We have another prime number over here. There is only one number in between, and this one number is a composite number. PCP. Okay, this is how you understand it. Now, let's look at the examples. He says 3 and 5. Is 3 a prime number? Yes. Is 5 a prime number? Yes. So in place of P1, if I put 3, and in place of P2, if I put 5, what is the number that should be there in between? There should be only one composite number. What is the number between 4? What are the factors of 4? 1, 2 and 4. That means the factors are greater than 2, right? Therefore, 4 was a composite number. Therefore, 3 and 5 are twin primes. 3 is a prime number. 5 is a prime number. The number in between them has to be a composite number. Yes?
So, twin prime numbers are the two prime numbers which are beside the composite number, right?
The composite number should be in between the prime numbers. Look, imagine your mom, imagine your dad. Okay? Imagine your mom, imagine your dad. Both of them are primes. Okay?
Okay.
Now there is this little small u in between. U should be composite. This is the definition of twin prime. Very clear?
Yes, sir. So, sir, that means the between number of two primes should be a composite number.
Yes. Now look at the examples. If I take 11 and 13, 11 is a prime number, 13 is a prime number. What is the number that comes in between these two? 12. 12 is a composite number. Therefore, 11 and 13 are twin primes. Clear?
Yes, sir.
Let's take another example. 41, 43. This is your mom. This is your dad. You are in between and you should be composite. 42. 42 is a composite number. Correct. Therefore, 41 and 43 are said to be twin primes. Is the idea clear, guys? Is the understanding clear? So, what is something that we have observed in all our definitions? 3 and 5, 5 and 7, 11 and 13, 17, 19, 29, 31, 41, 43, 59. What is it? Is there a common observation over here, guys? Anyone who has observed something over here? I cannot alternate between the screen and the chat. Anyone who has observed something over here? Yeah, are 7 and 11 twin primes, guys? 7 is a prime number, 11 is a prime number. But what are the numbers in between? We have 8, which is a composite number. We have 10, which is a composite number. We have 2 composite numbers. But what is the idea that we have to get? There's only one child in between. We don't have 2 children. So therefore 7 and 11 are not twin primes. But in all these examples, is there a common observation that we have? Is there a pattern that we see in 2 twin primes? Anyone? We see that the difference between 2 twin primes, the difference or the subtraction in layman's language is always 2. 5 minus 3 is 2, 7 minus 5 is 2, 13 minus 11 is 2, 19 minus 17 is 2, 29 minus 31 minus 29 is 2. Correct? If I ask a question, there is a number which is of the form 2k, which is divided by the difference of twin primes. What is the remainder? Let me put it on a fresh screen. My question is, there is a number which is in the form of 2k. It is divided by the difference of twin primes. what is the remainder? Anyone who can give this answer? Simple concept that we studied. I've just tried to play around with it. There is a number. It is in the form of 2k. It is divided by the difference of twin primes. Say these two twin primes are A and B. What is the remainder?
So,
Hmm?
but if we need to divide them, we need to know the answer. I mean, we need to know the numbers, right?
Correct. I am not giving you the numbers.
Yeah, but then how will we give you the quotient and remainder?
That's what I want. That's where I want you guys to think. Now look, guys, what does 2k? What idea does 2k give you? Where did we discuss?
2 multiplied by one number.
Where did we discuss the concept of 2k? Any even number? Correct? Any even number can be written in the form of 2k, guys. Does it ring a bell?
No.
Correct? That means our numerator is nothing else but an even number. Instead of saying even, I told you it is in the form of 2k. I'm just trying to trick you guys and confuse you. The concept is remaining the same. That means assume any even number. 4, 6, 8, 10, whatever you want. Yashika told me, sir, you have not given us the numbers. How are we supposed to solve? Assume anything. What is the denominator, guys? Difference of twin primes. What was our observation? When we discussed 11 and 13 are twin primes, what was the difference between these two? I told you there is something common between all of them.
There's only one child. Only one composite number.
Correct. But the difference between these two prime numbers is always 2. 13 minus 11 is 2. 17 and 19 are twin primes. Beach mein there is 18. 19 minus 17 is again 2. 3 and 5 are twin primes. Beach mein you have a child which is 4. Difference between 5 and 3 is again 2. What is my denominator? Difference of twin primes, which is nothing but 2. Correct? Instead of giving you the number 2, I wrote it in the form of a statement. I said difference of twin primes. What is the question? My question is simple now. There is an even number. I am dividing the even number by 2. What is the remainder? Now guys tell me, any random even number divided by 2. What is the remainder? Jaldi, are you guys asleep? Do you want to eat my chocolate?
No, sir.
Any even number when I divide it by 2, what is the remainder that I get? Remainder. Take any even number. No. Take 6. 6 divided by 2. What is the remainder? 0. Take 8. 8 divided by 2. Remainder 0. Take
0, right?
Pardon?
0.
Exactly. Any even number, guys. What is an even number? An even number is a number which when divided by 2 gives a remainder 0. Isn't that what I'm asking? It's an even number. Take any even number, Yashika. 8, 10, 10,000, 1 lakh. Anything divided by 2, what is the remainder? 0. Is this very clear? Did you like the question? Did you see how I changed something very basic just to test your understanding? Is the idea very clear now? Yeah, 0. Obviously, any number if I divide it by 2, I'm going to get 0, right? That's what I was trying to understand. Yeah. Oh.